This conference will now be recorded.
Dear students, come to this today's class. Please give me the response. Can you see this slide on the cell phones? The coplanar concurrent force system. Is it visible on the cell phone screens? Can you see this slide on the cell phone screen? Okay, thank you. So in the today's class, okay, thank you. In the today's class, I am going to explain you the determination of resultant force of the coplanar concurrent force system. What are the methods available? How can you find out? How can we find out the resultant force of the coplanar concurrent force system? We know that force system is number of forces. Resultant force is only one force. But the resultant force has the same effect on the rigid body as that of the force system. So we are going to discuss the determination of the resultant force of coplanar concurrent force system. Already in the previous classes, we discussed the different types of force systems. In that, I explained this coplanar concurrent force system. Coplanar means same plane. So check this title carefully. Here we have force system. Force system means number of forces. Coplanar means same plane. Concurrent means, I explained this also in the previous classes. Concurrent means if all the forces line of actions passing through the same point. We know that the force has the point of application characteristic. Force has the point of application. If all the forces in that force system, line of action of all forces in the force system lying on the same plane and passing through the common point, same point of application, we call that force system as a coplanar concurrent force system. So this is that coplanar concurrent force system in the body, in the rigid body. So like this. Here, all forces, we have number of forces, F1, F2, F3, F4, F5. Number of forces are there. These forces are different magnitudes, different line of actions. But all forces line of actions lying on the same plane. Since all forces line of actions lying on the same plane, we call it as coplanar force system. And also another important point is check this common point. Here in the diagram, look at this point. All the forces line of actions passing through the same point. This is the common point of application for all the forces. Then we call this force system as the coplanar concurrent force system. That concurrent means, the term concurrent means all the line of action of forces passing through the same point. We call this force system as a coplanar concurrent force system. In the today's class, I am going to discuss with you what are the methods available to find out the resultant force of this coplanar concurrent force system. So first understand what is meant by coplanar concurrent force system. Force system means number of forces with different magnitudes, different line of actions. If all the forces line of actions lying on the same plane and passing through the same point of application, we call that force system as a coplanar concurrent force system. All forces line of actions lying on the same plane, passing through the same point of application. So this is a coplanar concurrent force system. Now, what are the methods available to find out that resultant force of coplanar concurrent force system? What are the methods available to find out the resultant force of coplanar concurrent force system? To find out the resultant force of coplanar concurrent force system, we have two methods. One is called graphical method. Next one is called analytical method or the method of projections. We have two methods to find out the resultant force of the coplanar concurrent force system. The first one is called graphical method. The second one is called the analytical method or the method of projections. First, we will discuss what is this graphical method. How can we use the graphical method to find out the resultant force of coplanar concurrent force system? Next, we will discuss the analytical method or the method of projections to find out the resultant force of coplanar concurrent force system. So to determine the resultant force of the coplanar concurrent force system, we have two methods. What are those two methods? One is the graphical method. Next one is the analytical method or the method of projections. So first we are going to discuss what is this graphical method. How can we use this graphical method to find out the resultant force of the coplanar concurrent force system? In order to understand, please listen everyone, in order to understand this graphical method to determine the resultant force of coplanar concurrent force system, first we must understand what is meant by the graphical representation of force. Before going to discuss the graphical method to determine the resultant force of coplanar concurrent force system, first we must discuss what is meant by the graphical representation of force. Dear students, we know that the force is a physical quantity. It is not imaginary, please. It is a physical quantity, a real physical quantity. Force has magnitude as well as direction. Force has magnitude as well as direction. Then what is meant by the graphical representation of force? Check this diagram in the cell phones. In this diagram, the force is acting on the rigid body. So check this diagram, please. Here, the rigid body is subjected to the force F bar. How much is the magnitude? 10 newtons. This is the real force. In the diagram, the rigid body is subjected to force F bar of 10 Newton magnitude. This is the line of action of force F bar on the rigid body. We call this force as the real force. We call this force as the real force acting on the rigid body. But sometimes we must draw the real force acting on the rigid body on the paper. On the white paper, sometimes we have to draw the real force acting on the rigid body. When we are drawing, please listen everyone, when we are drawing the real force acting on the rigid body on the paper, that is called graphical representation of force. Graphical representation of force means when the real force acting on the rigid body is drawn on the white paper. Here this is the real force. It is acting on the rigid body, not in the white paper. But we are preparing this real force acting on the rigid body on the white paper. That procedure is called graphical representation. When we prepare the real force acting on the rigid body on a paper, we call that as the graphical representation of force acting on the rigid body. Now, how can we prepare? How to prepare the real force acting on the rigid body on the white paper? So please follow this carefully. Before going to discuss the graphical method, first of all, you should know what is meant by graphical representation of force. Then only you can understand that graphical method procedure. So just now I discussed with you to find out the resultant force of coplanar concurrent force system. We have two methods, graphical method and the next one is analytical method. In order to understand the graphical method, first of all, you should know what is meant by the graphical representation of force. Force is a real physical quantity. It is acting on the rigid bodies, not in the white paper. But the real force acting on the rigid body can be prepared on the white paper. Here in the first diagram, the real force is acting on the body. This is the direction of the force or the line of action of force, and this is the magnitude of force. We are going to prepare this real force acting on the body on the white paper. That procedure is called the graphical representation of force. Then the question is how to prepare the real force acting on the body on the white paper. There is a procedure. In order to draw the real force acting on the body on a white paper, we have a procedure. Please listen to that procedure. So here I am going to explain you the real force preparation on the white paper or on the drawing sheet. So when you are preparing the real force on the white paper, first select a point in the white paper, that is point A. First select the point A on the white paper. From point A, draw a straight line. From point A, draw a straight line such that this straight line is parallel to the direction of the real force. So please follow this procedure carefully. I am going to explain the real force preparation on the white paper. When you are going to prepare the real force acting on the body on the white paper, we have some procedure. We must follow the procedure when we are preparing the real force acting on the rigid body on the white paper. In the preparation, first on the white paper, select the point, take point A. From that point A, draw a straight line on the white paper such that the straight line is parallel to the direction of the real force. So check this straight line. From point A, I draw a straight line such that this straight line is parallel to the direction of the real force. Then take the length of this straight line. Take the length of this straight line such that the length of this straight line represents the magnitude of the real force. Take the length of this straight line such that this straight line length represents the magnitude of the real force. What is the real force magnitude? 10 newtons. So in order to select this length of the straight line, I am using this equation called scale. This equation I am using 1 centimeter length of straight line is equal to 1 Newton magnitude of the real force. This is called the equation of force scale. In the engineering graphics or engineering drawing, you might have studied this scales. So in that engineering drawing, when you are studying that scale, you can easily understand this. So I am going to decide this length of the straight line. The length of this straight line is equal to the real force magnitude. What is the real force magnitude? 10 newtons. So select 1 centimeter length of this straight line is equal to 1 Newton force. If this force is 100 newtons, then select 1 centimeter is equal to 10 Newton. If force is large value, accordingly you can select this. 1 centimeter length of the straight line is equal to 1 Newton force. What is the real force magnitude? 10 newtons. So the length of the straight line is equal to 10 newtons, 10 centimeter. So 1 centimeter length is equal to 1 Newton. So 10 centimeter length is equal to 10 newtons. That is nothing but the real force magnitude. So select this length of the straight line such that the length of the straight line is representing the real force magnitude. Then at the end of the straight line, indicate the direction of force in the form of arrow. Then this straight line AB on the white paper. The straight line AB on the white paper is called the graphical representation of the force F bar. F bar is the real force acting on the rigid body. The straight line AB with arrow is in the white paper. This straight line with arrow is parallel to the real force direction. The length of this straight line is equal to the real force magnitude. Then we call this straight line AB as the graphical representation of real force F bar. Since the straight line AB is having the arrow in the direction of the real force, you can call this AB as a vector, that is AB bar. According to vectors, the line AB bar is equivalent to the real force F bar, that is this equation. AB bar is equal to F bar because the direction of the vector AB bar is in the direction of the real force. The length of this vector AB bar is equivalent to the real force magnitude. According to vectors notation, this AB bar vector is equal to the force F bar vector. This is called the graphical representation of the real force acting on the rigid body. So select the point A in the white paper. Draw a straight line in the white paper so that the straight line is parallel to the real force direction. Then select the length of the straight line. According to convenient force scale, 1 centimeter length of the straight line is equal to 1 Newton force magnitude. the real force magnitude is 10 Newton. So the length of the straight line is 10 centimeter. At the end of the straight line, indicate the arrow. Take this straight line as AB. Then this straight line AB is a vector because it is having arrow. Then this AB vector AB bar is the graphical representation of the real force F bar. So in the vector notation, you can write the relationship as AB bar is equal to F bar, because the real force F bar is represented in the white paper by means of this vector AB bar. The direction is parallel to force direction. The length gives the real force magnitude. We consider this AB bar vector is equivalent to the real force F bar. This is called the graphical representation of the force acting on the rigid body. With this graphical representation knowledge, I am going to discuss with you the graphical method to determine the resultant force of the coplanar concurrent force system. Just now we discussed, to determine the resultant force of coplanar concurrent force system, we have the graphical method followed by analytical method. What is this graphical method? How can we use the graphical method to find out the resultant force of the coplanar concurrent force system? Coming to this graphical method. In the graphical method, we are going to find out the resultant force of coplanar concurrent force system on the white paper, not by using the equations. In the graphical method, on the white paper, we can find out the resultant force of coplanar concurrent force system. Since we are determining the resultant force on the white paper, we are calling this procedure as graphical methods, not by using the mathematical equations. By preparing the forces on the white paper in the graphical method, by preparing the force on the white paper, we can find out the resultant force of the coplanar concurrent force system. So we are calling this procedure as the graphical method. In the graphical method, we have three procedures to find out the resultant force of coplanar concurrent force system. Graphically, we have again three methods. One is called the parallelogram law of forces. Second one is called the triangular law of forces. Third one is called the polygon law of forces. These three are the graphical methods to find out the resultant force of coplanar concurrent force system. So please everyone, check these three methods in the graphical method. In the graphical method, we are going to find out the resultant force of coplanar concurrent force system on the white paper. By preparing the forces on the white paper, just now we discussed that graphical representation of force. The real force can be prepared on the white paper. That is called the graphical representation. By using that graphical representation of force in the graphical method, you can calculate the resultant force of the coplanar concurrent force system. In the graphical method, again we have three sub procedures. First one is called the parallelogram law of forces. Second one is called the triangular law of forces. Third one is called the polygon law of forces. Dear students, in the lower classes, perhaps in the junior inter, you might have studied that parallelogram law of vectors. Please remember that parallelogram law of vectors that you studied in the lower classes. In the lower classes, you studied that parallelogram law of vectors by considering P bar and Q bar vectors. Please remember that parallelogram law of vectors you studied in the lower classes. That same parallelogram law you studied in the lower classes, that parallelogram law for two vectors P bar, Q bar. In the parallelogram law, you calculate the resultant vector R bar. Please remember that parallelogram law of vectors. P bar, Q bar are taken as the adjacent sides of the parallelogram. Parallelogram has four sides. In that parallelogram, the opposite sides are parallel to each other, equal in length. You studied in the lower classes definitely. So in the junior inter, you might have studied this parallelogram law of vectors. In the parallelogram law of vectors, the two vectors P bar, Q bar are taken as the adjacent sides of the parallelogram. Then the diagonal of the parallelogram passing through the common point of P bar Q bar is the resultant vector R bar. In that parallelogram law, you studied the equations also. R is equal to root of P square plus Q square plus 2PQ cos theta. Please remember that in the intermediate junior level. The same parallelogram law we are going to apply in this coplanar concurrent force system. Since here we are applying the parallelogram law for forces, we are calling that as parallelogram law of forces. You might have studied this triangular law also in the lower classes, triangle law of vectors and also polygon law of vectors. Same we are going to study in this graphical method for the forces. So in the graphical method, again we have three sub methods: parallelogram law of forces, triangle law of forces, and polygon law of forces. All these three are graphical methods. On the white paper, by drawing the forces on the white paper, by applying these three laws, we can calculate the resultant force of the coplanar concurrent force system. So we are calling these three methods, parallelogram law of forces, triangle law of forces, and polygon law of forces, as the graphical methods to find out the resultant force of the coplanar concurrent force system. Now coming to the first one, the parallelogram law of forces. Already you have the knowledge on parallelogram law of vectors. Same knowledge here also. What is this parallelogram law of forces? You can apply the parallelogram law of forces to find out the resultant force of only two coplanar concurrent forces. So check this diagram in the cell phones. Please give me the response. Can you see this picture on the cell phones? Is it visible on the cell phones? Please give me the response. Sir. Okay, ma, thank you. So please everyone. Visible, sir. Okay, ma, thank you. Please everyone look at that picture on the cell phones. In that picture, the rigid body is subjected to two forces, F1 bar, F2 bar. Two forces, F1 bar, F2 bar. In your intermediate, you studied this F1 bar as P bar. You studied this F2 bar as Q bar. Only the difference. Check this diagram. Here the rigid body is subjected to two forces, F1 bar, F2 bar. These two forces lying on the same plane, and these two forces are passing through the same point of application. So these two forces are the coplanar concurrent force system. By using this parallelogram law of vectors, parallelogram law of forces, we can find out the resultant force of these two forces, F1 bar, F2 bar. By using the parallelogram law of forces, we can find out the resultant force, that is called FR bar. FR bar is the resultant force of F1 bar, F2 bar. Now, what is this parallelogram law of forces? How can we use this parallelogram law of forces to find out the resultant force of F1 bar, F2 bar? Please remember, the parallelogram has four sides. In the parallelogram, the opposite sides are equal in length, parallel to each other. In the parallelogram, the opposite sides are parallel to each other, equal in length. Then in that parallelogram, we have adjacent sides. Now, to apply that parallelogram law of forces, to find out the resultant force of F1 bar, F2 bar, first prepare this F1 bar graphically on the white paper. Prepare the force F1 bar graphically on the white paper. So please check the next diagram. This is the diagram. This diagram is prepared on the white paper. So in that white paper, take that force F1 bar graphically. So in the white paper, take the point O. From point O, draw a straight line, so that this straight line from point O parallel to the direction of the force F bar. F bar is the real force. We are preparing this on the white paper. This is a graphical representation. The parallelogram law is a graphical representation. It is on the white paper, not on the other things. So on the white paper, we are preparing this parallelogram. So here, select the point O, draw a straight line on the white paper, so that the straight line is parallel to the force F1 bar. Select the point A on that straight line. So this length OA is the magnitude of force F1 bar. The length OA is the magnitude of force F1 bar. Indicate the arrow in that length in the line OA so that this arrow is in the direction of the force F1 bar. So we can call this line OA, the vector OA bar is equivalent to force F1 bar. This is the real force F1 bar. I am going to discuss with you how can we apply the parallelogram law of forces to find out the resultant force of F1 bar and F2 bar. First, prepare this F1 bar graphically on the white paper. So on the white paper, select the point O. Draw a straight line on the white paper. This straight line is parallel to the F1 bar force direction. Select the point A on the straight line. So this length OA is equivalent to the force F1 bar magnitude. Indicate the arrow in the straight line OA. So this arrow is in the direction of the force F1 bar. Then the vector OA bar is equal to the force F1 bar. OA bar is the graphical representation of force F1 bar. Then from that point O, draw the another straight line. Draw the another straight line from that point O so that this straight line, another straight line is parallel to the direction of the force F2 bar. That is the real force. From point O on the white paper, draw the another straight line. That straight line is parallel to direction of the force F2 bar. Select the point B on that straight line. According to the scale, select the point B on that straight line. So this length OB is equal to the F2 force magnitude. The length OB is equal to F2 force magnitude. Indicate the arrow on that straight line. This arrow is in the direction of the force F2 bar. So this vector OB bar is equivalent to force F2 bar. So in the white paper, in parallelogram law of forces, to find out the resultant force of F1 bar and F2 bar in the white paper, first we prepare this force F1 bar graphically. This OA bar is graphical representation of the force F1 bar. Then we prepare this OB bar vector. We prepare this force F2 bar graphically by using this vector OB bar. OB bar is the graphical representation of force F2 bar. We call this OA and OB as the adjacent sides of the parallelogram. The side OA and the side OB as the adjacent sides of the parallelogram. Then complete the parallelogram. In the parallelogram, these opposite sides OA and BC parallel to each other, equal in length. The length of OA is equal to length of BC. Similarly, the length of OB is equal to length of AC, parallel to each other and equal in length. That is the property of the parallelogram. Complete the parallelogram OA-BC. Then in this parallelogram OA-BC, O is the common point for the forces F1 bar and F2 bar. These two forces F1 bar, F2 bar are meeting at point O. Then this diagonal passing through point O, that is OC, is the resultant force of F1 bar, F2 bar, that is FR bar. Measure this length of this diagonal OC. This is the arrow of this resultant force. Then this length of the diagonal OC is the magnitude of resultant force FR. So this diagonal OC bar passing through this point O. What is that point O? It is the common point of the forces F1 bar, F2 bar. The diagonal of the parallelogram passing through this point of intersection of the two forces gives the resultant force of FR bar of F1 bar and F2 bar. This procedure is the parallelogram law of forces. So by using that parallelogram law of forces, you can find out the resultant force of only two coplanar concurrent forces. You can apply this parallelogram law if the rigid body is subjected to only two coplanar concurrent forces F1 bar and F2 bar. This is totally graphical procedure. We are preparing this parallelogram on the white paper. So since this parallelogram is prepared on the white paper, to find out the resultant force of F1 bar, F2 bar, we call this as the graphical method. The parallelogram law of forces is a graphical method. So in the previous diagram, we observe the real forces F1 bar, F2 bar acting on the rigid body. Theta is the angle between them. To apply the parallelogram law for these two forces to find out the resultant force FR bar, first we prepare this F1 bar graphically on the white paper. The vector OA bar is the graphical representation of force F1 bar. The vector OB bar is the graphical representation of the force F2 bar on the white paper. OA, OB are called the adjacent sides of the parallelogram. Since OA is parallel to F1 bar, OB is parallel to F2 bar, the angle between the forces, the lines OA and OB is also equal to theta. Because OA is parallel to force F1 bar, OB is parallel to force F2 bar. In this parallelogram also, the angle between the OA, OB is equal to theta. Complete the parallelogram. In the parallelogram, the side OA, side BC are equal, parallel to each other. The side OB, side AC are equal, parallel to each other. Complete the parallelogram OA, BC. Then the diagonal passing through point O. O is the common point for the forces F1 bar, F2 bar. This is called point of intersection. The diagonal of parallelogram passing through point of intersection is the resultant force. So this diagonal OC bar is the resultant force FR bar of the forces F1 bar and F2 bar. Coming to the parallelogram law statement. What is the statement of parallelogram law? Just now we discussed. So please follow this statement carefully. If two forces, that is F1 bar, F2 bar, if two forces acting simultaneously at a point in the rigid body, because these two forces are concurrent forces, F1 bar, F2 bar are the concurrent forces, so they are acting at a point on the rigid body represented. This is graphical representation. Represented in magnitude and direction. You know that in the graphical representation, the vectors obeys the direction of the force and also the magnitude of the force. So in the parallelogram law, two forces acting simultaneously at a point are represented in magnitude and direction by the adjacent sides of the parallelogram. So just now we discussed in that parallelogram, OA, OB are the adjacent sides. OA bar is the graphical representation of force F1 bar. OB bar is the graphical representation of force F2 bar. So in the parallelogram law, we represented the two forces graphically as the adjacent sides of the parallelogram. So direction, adjacent sides of the parallelogram drawn from a point, that is point O. Drawn from a point, then the resultant force is represented in magnitude direction by the diagonal of the parallelogram passing through the same point. This is the parallelogram law forces statement. In the junior intermediate, you studied this same statement, but for the vectors P bar and Q bar. So please remember that parallelogram law of vectors. The same parallelogram law here also we are using, but for the forces. So we are calling it as parallelogram law of forces. So you can apply this parallelogram law of forces to find out the resultant force of two forces F1 bar and F2 bar. So just now I explained. Take that force F1 bar graphically as the side OA of the parallelogram. Take the force F2 bar graphically as the side OB of the parallelogram. Complete the parallelogram. Theta is the angle between the forces F1 bar, F2 bar. Here also theta is the angle between the sides OA and OB. Then the diagonal of the parallelogram OC bar is the resultant force of the forces F1 bar, F2 bar. Please remember, in the intermediate, you studied this R bar, resultant vector. You know that in the parallelogram law, the resultant vector magnitude R is equal to root of P square plus Q square plus 2PQ cos theta. Here, P is equal to F1, Q is equal to F2, R is equal to FR. So apply that parallelogram law forces the parallelogram law vector equations here. From the parallelogram law of vectors equation, so check this diagram please. This is resultant force. Earlier, the rigid body is subjected to F1 bar, F2 bar. By using the parallelogram law, we calculate the resultant force FR bar. If I apply that resultant force on the rigid body, I can remove the two forces F1 bar, F2 bar. Since the resultant force has the same effect on the rigid body as the forces F1 bar, F2 bar, once I calculate the resultant force, apply the resultant force on the rigid body, remove these two forces from the rigid body. So instead of two forces, we apply only one force on the rigid body, because FR bar is the resultant force of F1 bar and F2 bar. We know that FR bar is resultant force of F1 bar, F2 bar. Then the F1 bar, F2 bar are called the component forces of FR bar. That is this resultant force. In the vector addition, FR bar is equal to F1 bar plus F2 bar. That is this equation. The resultant force FR bar is equal to F1 bar plus F2 bar. FR bar is called the resultant force of F1 bar, F2 bar. F1 bar, F2 bar are called the component force of FR bar. This is the vector addition. FR bar is equal to F1 bar plus F2 bar. Then this resultant force magnitude FR is equal to root of F1 square plus F2 square plus 2F1 F2 cos theta. That is this magnitude of the resultant force. You studied this also in the parallelogram law of vectors. R is equal to root of p square plus q square plus 2pq cos theta. Here p is equal to F1, q is equal to F2. So the resultant force magnitude Fr is equal to root of F1 square plus F2 square plus 2F1 F2 cos theta. Then if the resultant force Fr making an angle alpha with the force F1 bar. If the resultant force Fr bar making this angle alpha with the force F1 bar, tan alpha is equal to, we might have studied in the intermediate, tan alpha is equal to q sin theta divided by p plus q cos theta. So same equation here also. In this resultant, in this parallelogram law of forces, p is equal to F1, q is equal to F2. So this tan alpha, the angle made by the resultant force with the direction of the force F bar. Theta is the angle between F1 bar, F2 bar. Please follow this carefully. Theta is the angle between F1 bar, F2 bar, and alpha is the angle between resultant force and F1 bar. So tan alpha is equal to F2 sin theta by F1 plus F2 cos theta. In the intermediate, you studied this tan alpha is equal to q sin theta by p plus q cos theta. Here q is equal to F2, p is equal to F1. So tan alpha here is F2 sin theta by F1 plus F2 cos theta. This is the parallelogram law of forces to find out the resultant force of two coplanar concurrent forces F1 bar, F2 bar acting on the rigid body. Now coming to this diagram, please. Check this diagram, everyone. Look at this triangle OAC. In this triangle OAC, check this triangle OAC. In this triangle OAC, OA is the force F1. In the triangle OAC, please check this, everyone. In the triangle OAC, OA is the force F1. AC, since it is a parallelogram, the length AC is equal to length OB. OB is the force F2. So this length AC is the force F2. So in the triangle OAC, this length OA is the force F1. The length AC is the force F2. The length OC is the resultant force Fr. So here we have this triangle OAC. In the triangle OAC, the OA is equal to F1, AC is equal to F2, OC is equal to Fr. Then here this angle is alpha. So at point O, the angle is alpha. At point C, the angle is beta. Then this line AC with horizontal makes the angle theta. Because this AC is parallel to AB, OB. The line OB with horizontal making the angle theta. The line AC also with horizontal making the angle theta. Then this remaining angle. At point A, the remaining angle is 180 minus theta. At point O, the angle is alpha. At point C, the angle is beta. At point A, the angle is 180 minus theta. So take this triangle OAC. Everyone, please watch this. Take this triangle OAC. In that OAC triangle, at point O, angle is alpha. At point C, angle is beta. At point A, angle is 180 minus theta. Apply the sine rule. Apply the sine rule for this triangle OAC. According to sine rule, the side OA, according to sine rule, OA divided by sine of opposite angle beta. So OA divided by sine beta is equal to F2. This is the side, second side. Now AC second side. AC divided by opposite angle is alpha, sine alpha. So apply the sine rule for this triangle OAC. According to the sine rule, OA divided by sine beta is equal to AC divided by sine alpha is equal to OC divided by sine 180 minus theta. With respect to this side OC, the opposite angle is 180 minus theta. So by considering this triangle OAC in this parallelogram, we can apply the sine rule. From the sine rule, you will get this equation. So here, OA divided by sine beta is equal to AC divided by sine alpha is equal to OC divided by sine 180 minus theta. Here, OA is equal to force F1. AC is equal to force F2. OC is equal to force F4. Sine 180 minus theta is equal to sine theta. So from the parallelogram diagram between the forces F1, F2, Fr, we have another relationship. F1 by sine beta is equal to F2 by sine alpha is equal to Fr by sine theta. So in the parallelogram law of forces, we have three equations. Equation 1, it is the resultant force magnitude. Equation 1. Equation 2, it is the resultant force direction. Alpha is the angle made by the resultant force with force F1 bar. Equation 1 is the resultant force magnitude. Equation 2 is the resultant force direction. Then between the forces F1, F2, Fr, we have another relationship in the parallelogram law. That is this other relationship. F1 by sine beta is equal to Fr by sine alpha is equal to F2 by sine alpha is equal to Fr by sine theta. So check that angles alpha, beta, theta in the previous diagram. Alpha is the angle between the forces F1 and Fr. Theta is the angle between the forces F1 and F2. Beta is the angle between the forces Fr and F2. So here this theta is the angle between F1 and F2 forces. Alpha is the angle between F1 and Fr. Beta is the angle between F2 and Fr. Then the relationship between F1, F2 and Fr. F1 divided by sine beta is equal to F2 divided by sine alpha is equal to Fr divided by sine theta. That is this parallelogram law of forces in the graphical method. Dear students, if you have any doubts in this parallelogram law of forces, you please discuss with me. If you have doubts in this graphical method, parallelogram law of forces, you please discuss with me. Any doubts, students, in this parallelogram law of forces?
No, sir.
What about remaining? 34 students are there in the class. Only Jaykumar gave the reply.
No doubt, sir.
Thank you, 107. Thank you very much. It is similar to, please follow this carefully. This parallelogram law of forces is similar to the parallelogram law of vectors. But there you studied that parallelogram law of vectors by P bar Q bar vector. The same we are applying here for the forces. F bar, F1 bar is one force, F2 bar is the second force. Both are acting on the rigid body. Both are acting at the same point. F1 bar, F2 bar are the real forces because they are acting on the rigid body. To find out the resultant force of F1 bar, F2 bar, we are using this graphical parallelogram law of forces. Parallelogram law is a graphical method. Then by analyzing the triangles and the remaining concepts in the parallelogram law, we got the equations for Fr, tan alpha and remaining things. Parallelogram law is entirely graphical method, but we apply the trigonometry on the parallelogram law, OABC. By applying the trigonometry on the parallelogram OABC, we got the equation 1, resultant force magnitude. We got the equation 2, direction of the resultant force. We got the equation 3, the relationship between F1, F2 and Fr. So this is the first graphical method, the parallelogram law of forces, to find out the resultant force of the coplanar concurrent force system. Then in this parallelogram law, we have some numerical problems. I will discuss one numerical problem in this parallelogram law, simple numerical problem. Then in the next class, I will discuss the remaining numerical problems in parallelogram law. Please everyone look at this numerical problem in parallelogram law of forces. Read that problem. Two forces of magnitudes 10 Newton and 8 Newton are acting at a point. So here in the numerical problem, we have two forces 10 Newton and 8 Newton. First force F1 is equal to 10 Newton. Second force F2 is equal to 8 Newton. Those two forces are acting at a point. So it is concurrent force system. If the angle between the two forces is 60 degrees, that is theta. The angle between F1 and F2 is theta 60 degrees. Determine the magnitude of the resultant force, that is Fr. Simple problem. For 2 marks, this type of problems you will get in the examination. So in this numerical problem, they given the force F1 magnitude 10 Newton. They given the force F2 magnitude 8 Newton. They given the angle between the forces F1 and F2 theta 60 degrees. We are asked to find out the resultant force magnitude Fr. So coming to the steps for this problem. So the first force, the magnitude of first force F1 is equal to 10 Newton. Then the magnitude of second force F2 is equal to 8 Newton. The angle between the forces F1 and F2 theta is equal to 60 degrees. We are asked to find out the resultant force magnitude Fr. Take Fr is the magnitude of the resultant force F1 F2. You know that in the parallelogram law of forces, the resultant force magnitude, the magnitude of the resultant force Fr is equal to root of F1 square plus F2 square plus 2F1 F2 cos theta. Substitute on the right hand side. F1 is 10 Newton, F2 is 8 Newton, theta is 60 degrees. Simplify this, you will get this resultant force magnitude is equal to 15.62 newtons. So like this, we have some numerical problems in parallelogram law of forces. In the tomorrow class, we will discuss the different types of numerical problems in parallelogram law of forces. These problems are regularly repeating in the semester examination. So please attend the tomorrow class. I will discuss number of problems in parallelogram law of forces. Then we will discuss the other graphical methods. We have triangle law of forces and polygon law of forces. The remaining two also discussed in the next class. Okay, students, with this, I am going to stop the today's class. Thanks to one and all for joining the class. If you have doubts, you please discuss with me. Otherwise, you can leave the class.